I want to show you guys punching shear. I want you to Google it also and look at the failures and what they look like. What you'll see that they all have in common is that the item that sticks around, the column that sticks around, is in awesome condition. With that said, let's just quickly jump over to the NTSB, also the OSHA report photographs. This would be the column that the forearms, and I'll click to the forearms that they all talk about, and punching shear, punch out of diaphragm to that this number 11 had ability to punch out this part of the deck, and also through 12. It goes on and on in here, but also the OSHA report states it, and that's ultimately that looks what NTSB is stating it also. This punch out. I find it, their craftsmanship with sharing photographs and images is quite entertaining. It's stupid. Let's talk about the PSI also. This concrete of the deck and the PSI of number 12 and number 11 are all of the same PSI. The same PSI. Of course, reinforcement would change its strength as forces are applied to it, such as a rebar inside. They would strengthen the 8500 concrete to have a greater resistance because it now wouldn't fail under tension. Except for, let's look at the 11 guys drawing here. As you can see, which I like the ductwork inside here and all that, you can see that these columns are just some concrete with that's been dissected, or cross section shows it's going to have two pipes down the middle of two ductwork, piece of ductwork. And we're only talking going back to, yeah, that's a good image. We're going back to this column here. This is the 11 column rather. Reported the 11 column right here on 314. This is trash, and this is not, I just felt like, this is just ridiculous that these guys call themselves engineers over here, that to go down this line, and for NTSB to go down this line, or this is creating a shear off of there. Well, you know what? It pried it off. This doesn't have the ability, as far as I would ever see this having the ability to shear anything off. Not anything, but it has the ability to pry up. This is not the beginning of the failure of this deck system. It is creep inside the post-tension cables that, from whatever reason, through not calculating, adding to them. Let me give you a little more data on punching, and you guys can look it up yourself and see if you can find something that could. Okay, those are just diagrams, so that won't really work. This is some of the ways that we resist it. You see, this is the crack, but this would be the failure also if the dead load was there and you only put it in a girder system. If you think of that as a girder system, you would get these cracks like that. Number 12 leaning down. They have it punching out, which we don't have the ability to do. As I showed you in my styrofoam model, it doesn't have the ability to elongate, not without the deck moving first. Now, these are all ways to transfer the loads. This punching shear thing, transferring loads, if you think about it like that. Let's go to what it looks like in real life. There's a nice real life image of punching shear. And what do you notice? The columns are all in great condition. The columns, the verticals, right? There's the deck, part of the deck, but the verticals didn't buckle. The verticals did not buckle. They stood their ground. So for you to now tell me you have shearing, punch-out shearing going with this number 11, well, then that means just like in the real world, you would see, and we have real-world images, we would see that it would stand its ground. Does this look like it's standing its ground? What part of this member with all these huge cracks in them do you see this member standing its ground? I see it being torqued, twisted apart to failure. I don't see it standing its ground. I just want to do a fast video for you guys. You guys can Google punching shear, find the real world images, and you'll see one after another that the column is standing its ground. That you do not find buckling in this column. Well, maybe you might be able to find a touch, but I haven't found it with what I'm trying to share with you just now. And you can see it in multiple images. It stands its ground. It stands its ground on punch shear. So here we go here again. Back to this one. Standing their ground. This member is not standing its ground. It doesn't have the ability to stand its ground. It's gone. No punching shear. This is, as I said in previous videos, look at this thing. It's being torqued and twisted. That the deck is dipping, that the part of the tendons in the cable, in the deck, in the canopy, are acting like it's pulling inwards now like a spring. I'm going to do more videos on this, like a rubber band pulling in, able to lift this thing up. And it happened because they released the loads in number 11A down here, I believe, and I believe this is B. Once they relieved it, it would have failed completely had the B only been partially released, snugged, and it grabbed hold again. You know, that's a longer video. This video I want to still focus on just punching shear. Let's go to the very back, the very end of this, and let me rotate it this way to give. Great. I'm going to end it with this thought for you too, to explain my explanation of what we're looking at. Totally not, the report, I loved it up to that point, but I think it theoretically doesn't work out theoretically. Even theoretically, it doesn't work out because the data says something different than your theoretical. You can't have a theoretical and just throw data out the window. You got to account for all the data to work in your theory. Let me get you the back of this failure in the image. And I explained how this is that little blister on the back of this. It got blown out, bumped off, but not just blown out. I'm sorry. Let me get some clarity on that. It was also, because this was in the deck, we need to see the images when they were doing the deck, and then they added the uprights. We need to see the reinforcement. It's clear to me that the reinforcement was in the deck along with the blister, because you can see the height of it above the deck. This is the part that they're claiming 8,500 PSI, all broken up concrete. Is it 8,500 or is it 6,500? I get the PSIs a little mixed up right about now. That the 8,500 PSI came into contact with more 8,500 PSI with the reinforcement that may not be going across the path. It is across the path, but that reinforcement didn't find that this weak, broken up 8,500 PSI with the splits in it. It found this section to be weaker than that section we saw all broken up. That logically doesn't make sense, especially with the reinforcement there. That it would have just, it's like hitting a brick wall. But you see the upright here, the rods, the main bars are coming up like this. This is and that blister. That blister is this wide, sticking off the deck, installed while they did the deck, as per OSHA's reporting. That you're looking at the loads were here, and this became loose when they detensioned it. That allowed the canopied loads to go down 12. That dead load was stopped by the bar B, even though they loosened it up. It grabbed it, and the crack like hell images appeared. But that was because I think that bar was able to redirect those forces back into the canopy again. And what we looked at is that cracks went this far. And these would be the shear crack of the dead load of the number 12 column in a downward motion, and downward and up, because I talked about that in the other video, how we get a downward and up motion because it's not broken. You have to explain over here the cracks are elevated, not going in a downward motion towards the ground, but elevated. Now, you're telling me that a shearing created an upward force also? The only way that would create an upward force at this time is if it hit a hinge point to help do that. But it has to be a pretty big hinge point. But at that point, the only way to create the hinge is you got to let the deck creep down. And then you got to account for the post-tension bars that are in the canopy. They'll be doing what? Resisting it from falling down. No, it would actually create a torque action on it. Now, well, that's my other videos. It explains it all. This is on the ground. This is the bar that was supposed to go into the deck, as I understand. Two of them to crank it down. Again, for clarity, in my other videos I talk about that shearing couldn't happen because it can't go through this plastic. but this plastic turns out to be outside the shearing zone, if you will, the punch out shear that they're claiming has happened. So hopefully you'll watch the video again, understand what I'm saying again about the punch out. What punch out really looks like is that your column stands its ground and the other deals come around it. There's your punch out. So I hope that helps you understand it and why, how can anyone in a good engineering mind state that that member that's all trash has the structural integrity to push his way through all that steel that people are discounting the weight of the 12, and it's also the same PSI, and also have to go through its own reinforcement, which is A. I think this is post-tension rod A, and also B. How does it have that ability? To me, it's a magic ability. It's not possible. I do have an attitude that anything's possible. I guess I could. It's not possible in this case because I'd have to keep this intact to have that happen. I'd also have to lower the deck down. I'd have to have this whole thing, the canopy shift, where it want to push that out. That's how it'd be possible, but it didn't happen that way, so not possible because we have a video. So it's not possible for me to make that happen with the video evidence as part of it. So I find all those engineers over there lacking, most of them lacking in common sense, and yeah, whatever. You guys can say what you want to say. And the ones that come over here and watch me give me my 3-star thumbs down. If you do it again, I'm going to break your little finger off. Now you think about that. Nope, I thank you for putting me the thumbs down, you dummies. You can't help it. They're dumb. You can't help it. You actually helped me with the thumbs down. I just wanted to add this part. You actually still help my content because Google sees it as thumbs down is also positive because it's interaction. They don't know which way you're going. Thumb down for the content, thumb down for the person presenting, or thumbs down because you don't like something. They have no idea. They don't care. As long as it's interaction. That's why people troll people with a comment. Me, I'm just saying how dumb you are. You don't even know how to pay attention to what your thumbs down means. So here's the elevation here. I'm just proving your stupidity. But I'm also proving psychologically they have no choice but to respond back with the thumbs down or whatever. But this material here, there's nothing there. There is nothing there. This is the part they're claiming. Slid and sheared and pushed off 12 and punched through all that concrete. Yet, again, at the end of the video, this is what's doing the work. That's what's doing the work. That screwed up, trashed up member has the ability to do the work in their mind, this thing. That is just ridiculous. It's ridiculous. I find that any of those guys, anybody in here believes this is punched, you are no different than Denny Pate or anyone else that was participated in the failure of the structure. You would have arrived at the same decision of it's okay and walked out of the room like everybody else. So anyone that says that this punched out and it was the beginning of the failure, that this punch out was the beginning of the failure, not that the deck creeped and all that. This is the beginning, and that member with all that cracking had the ability to do a typical punch out and get upset. I don't care.